So what I wanted to talk about is forces and simple harmonic motion. So we've looked at types of forces. We've looked at things like tension, friction, normal forces, all that sort of stuff. We even looked at spring force. Now, forces in simple harmonic motion isn't describing a force, but it's describing types of forces. The term that's used is called a restorative force. The perfect example in the classic systems is a spring force. So if we remember the equation for spring force is negative kx. Okay, good old hook. That's the equation for a spring force. Now, what makes that a restorative force is that negative sign. If you remember that force is proportional to acceleration. Okay? So that means the acceleration of an object, if this is the only force acting on the object, of course, I mean, it may be balanced. In that case, obviously, there's no acceleration. But if it's an unbalanced system, if the only force is the force of the spring, that means that the acceleration is proportional to kx. Or another way of looking at that is acceleration is proportional to negative x. And that's what makes it restorative. If you took an object and you had it attached to a spring and you stretched the spring out, so here's its equilibrium position, but instead you've stretched it out an additional distance, this being x, then the force that that object is experiencing will be in the opposite direction. So the force that it's experiencing is in this direction, and the acceleration is in that direction. So it's wanting to restore the object back to its original position. I've stretched it out, and the force is in the opposite direction. It wants to pull it back. That's what makes it restorative. Now, to get simple harmonic motion out of that, the object is pulled back, it's stretched, and while you're doing that, you've given that object what's known as energy. It has this potential to do stuff. So you release it and it goes too far in that direction. So now you've compressed it, making the stretch or the compression in that direction, and then the forces switch direction, forcing that object to oscillate back and forth, going boing, 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 just like we saw in the simple harmonic motion equations. You saw this relationship between acceleration is equal to, remember, amplitude, negative amplitude, omega squared, and then maybe a sine function or a cosine function. Okay, we ended up with that relationship. Now this A is representing amplitude, and remember the other word for amplitude is position, maximum position. But you can see that the relationship between them, the acceleration is in one direction, the position is in the opposite direction, just like you have going on here. Okay, so you have this relationship, okay, the simple harmonic motion. Now gravity can be construed that way too, especially if you look at Newton's universal, which is in modern forces, which we haven't covered when we were talking about this stuff, but you'll see that the force is in the opposite direction of the position. If you consider an object here, okay, its position with respect to the center of the Earth is in the positive direction. It's pointing this way. But the force that that object is experiencing is in the opposite direction. So you get yourself some simple harmonic motion going around there. As a matter of fact, if you could drill a hole through the center of the Earth and you released an object, it would literally oscillate back and forth, going through the center of the hole, back up to the top. Now, of course, if you're removed, you have to remove air for it to continue to just oscillate over and over again. And as a matter of fact, it doesn't even need to go through the center of the Earth. You can have it being driven through from one point to another, and you'd still get that simple harmonic motion. But that's the critical component of simple harmonic motion, and why it's simple harmonic is that there's this restorative component, that the acceleration is proportional in one way or another to the position or the negative position, that the acceleration and the position are in opposite directions. That makes it restorative. Okay?